On today's episode, airliners are slower and less comfortable than they were half a century ago. Why? Today's episode is brought to you by Engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on Engineering.com TV today. The aerospace industry, especially airframers making commercial transports, has always fascinated me. Now, in the form of manufacturing where I started, automotive, designing and developing new products was a time-honored process of incremental improvements and well-understood timelines, costs, and ultimate profitability. Now imagine that your task is to engineer a new product which is so expensive to develop that its market failure will cause the bankruptcy of your company. Now that's the world that major airframers like Boeing face, and it's a major reason why great names like Lockheed, Convair, and Douglas have disappeared. But when they existed, they did great things. Douglas, Convair, and Boeing's early jetliners were all faster than today's aircraft, and back in coach, where I usually sit, we were a lot more comfortable as well. But as air travel became popular in the 1970s and oil prices increased, the imperative to deliver lower seat mile costs led to today's generation of slower, higher density, but much more fuel-efficient aircraft. But what if the industry had gone in a different direction? Now, I'm not talking about Concorde or the ill-fated Boeing 2707 supersonic airliner project, but this, the flying wing. Now part of the big Northrop Grumman Corporation, Northrop was a small manufacturer of innovative designs, and its founder, Jack Northrop, had a particular fascination with flying wings. Now there are lots of advantages to this design. A major one is a very large internal volume, introducing the intriguing possibility of airliners that are limited more by takeoff weight than by usable interior volume. Could every seat be a lie-flat seat? Well, possibly. Flying wings are used very successfully for stealth bombers, but the company's hopes in the late 1940s that military flying wings would spawn a new generation of comfortable, fast airliners, well, that never came to pass. Boeing later looked at another advanced design called the Sonic Cruiser, and that didn't happen either. Why? Well, put simply, the need to gamble the entire company on every new product means that every new product must be a sales success. And that means that it must be designed conservatively, and airlines generally punish out-of-the-box thinking. Or just as bad, they punish an aircraft that arrives into a changed market from the one for which it was designed. Now the Airbus A380 Super Jumbo is an example. So airframers change materials, use more efficient engines, add more advanced avionics, and package it all in an aircraft that would hardly look out of place on the ramp at any major airport in 1967. So what will it take to get someone to do to the aviation industry what Elon Musk did to the auto industry? Well, the short answer is, of course, dollars. Now, could a startup take on the airframe giants and do something radically different? Well, for any billionaires watching this, it could be a lot more challenging than flying into space. Well, that's it for today's episode of End of the Line, brought to you by Engineering.com. If you like this show, be sure to subscribe to our channel and click on the notification bell for our next episode. For our deeper engineering video series for the manufacturing professional, visit Engineering.com TV to watch exclusive shows like Manufacturing the Future, not found here on our YouTube channel. The link is in the description below. Thanks for watching.